Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017 Time Zone 1 in May, question number 3, which is a pretty classic question related to the mole calculation, in which two of the equations are being used. The first one, the mass over molar mass, and the second one, the volume of a gas over molar volume, both resulting in the number of moles calculation in this reaction. Let's see, they're asking, what is the expression for the volume of hydrogen gas in DMK Express finally produced at standard temperature and pressure when 0.3 grams of the magnesium is reacting with excess hydrochloric acid solution? So already given to you that the magnesium is going to be our limiting reactant, so which means the hydrochloric acid you can simply neglect it, right? And then given also the molar volume of an ideal gas under this standard temperature and pressure, which is going to be 22.7, a really classic constant that we always use in the IB syllabus, right? For this question, again, we should use back our simple techniques. Remember, whenever handling our chemical reactions and then given you certain information regarding the reactants and asking for the information about the product, we always use this what we call three steps approach. The first step is that we must calculate the moles that we have in hand. Just like this case, we should be having the moles of magnesium because we know mass over molar mass, which is going to be the number of moles, right? Secondly is what we call the mole ratio. Mole ratio is a really important concept relating to the understanding behind this equation, right? What this equation is suggesting is that 1 mole of the magnesium after a complete reaction should goes to also 1 mole of the hydrogen gas. So which means the mole ratio of our starting reactant and also the product, which is going to be 1-to-1 ratio because of this balance equation, the coefficient, which is 1-to-1. So that is like a bridging between the known data with our unknown data. So that's why what we call mole ratio. And so finally, the third step or the final step is that we arrive to the moles of our target. So in this case, my target, which is going to be hydrogen gas, right? And once I know the moles of the hydrogen gas that I'm going to have or produced after the reaction, I should know the volume, right? By simply do the expression volume over molar volume equals number of moles, right? Yeah, so with this understanding in mind, that we should apply this three steps approach, right? First of all, I just rewrite the equation here, so having more space. Magnesium plus the hydrochloric acid goes to magnesium chloride plus hydrogen gas, a really classic typical acid reaction, right? For now, what we are having is 0.3 grams of magnesium, which is given, right? And as we know, mass over molar mass, which is going to be 0.3 over the molar mass of magnesium that is given in the data booklet, so which is going to be 24.31. So that is the first step, right? We work out the moles of the given information, so that is magnesium. The next step, what's the next step again? The mole bridge, right? So the mole bridge here says magnesium and hydrogen gas, which is our target, which is in 1-to-1 ratio. 1-to-1 ratio. So that means here also having the same moles, right? Same moles to be 0.3 over 24.31, right? As the moles. So that's why finally, the third point is we get the moles, but then are we wanting to find just the moles? No, but we want the volume, right? But we have learned the relationship is that volume over the molar volume, which is also equals to the number of moles, right? So that means if we want back the volume, so we simply do the moles multiply the molar volume, right? So which is given, so that is going to be 32.7. So that's why finally we have the volume, which is equals to the moles 0.3 over 24.31, and then multiply back the molar volume, in this case 22.7. So that is our expression. Do we need to calculate this out? No, because no calculator is available. So that's why we only need you to express it in terms of this equation. So obviously in this case the answer is going to be B. The template of this kind of question is really standardized. Although the next time they obviously not asking the same exact question, still the technique of this what we call three steps approach is really critical in terms of handling all the mole calculations, especially in paper 1 multiple choice.